Welcome to Science Store online classes.
Don't forget to like our video and subscribe our YouTube channel for all the updates.
Hello dear students and welcome to CET JEE classes of the basic concepts, the preliminaries, and in that we are solving the problems from algebra. Okay, so we have already discussed in detail the concepts of indices, the product formulas, and then I have introduced the concept of logarithms. We have understood the formulas in detail, and now we will solve a few examples so that we understand where to use those formulas. Alright, so once you understand where to use those formulas, solve as many problems as you can, and that will help you to remember the formulas. Okay, just by learning the formula by heart you won't remember them. You have to use them in the problems, solve the problems using the formulas, then that formula will be remembered. Okay, you will remember that formula. Now coming to this first example, understand what is given here: 1 by log n to the base 2, 1 by log n to the base 3, and so on. Now I am using the reciprocal formula. See, what is the reciprocal formula? If you have log a to the base b, then when you write the reciprocal, then what happens is the base will shift. Okay, so they will shift their position, so base will be a and this goes here. Well, so that's the formula we have. So using this formula I'm going to write this. So this is like 1 see reciprocal, so I'm taking to the numerator, so this is log n, okay, log 2 to the base n, and then this is log 3, once again the same base n, plus you have log 43 to the base n. Now you have the next formula, that is log x plus log y, is it not? See, what you know is log x plus log y. See, I'll write base a. Base can be anything. Okay, now base can be anything. That doesn't mean that you can have separate bases. No, you should have the same base here. Okay, so but if you have 2, then you should have 2. You can have 3 also, you can have 4 also, you can have any base but the same bases in both the places. Well, so log xy to the base a. I hope you understood this. Log x plus log y is log xy. Okay, well, now use that formula here. Log 2 plus log 3 is log 2 into 3, and it goes on till 43. So everything will be multiplied here. So this is like a log 2 into 3 into 4. Okay, so it goes on till into 43. Well, now what is the meaning 2 into 3 into 43? The meaning of that is 43 factorial. See, I'll explain this, but let me write it first. See, this is log 43 factorial. Alright, now this is equal to, once again I'll take the reciprocal. See, when I bring it to the denominator, this will be log n and the base will be 43 factorial. Now let me, so that is option C. Alright, so option C is the answer, 1 by log n to the base 43 factorial. Now what is the meaning of this exclamatory mark? Okay, you may think that is exclamatory mark, but it is not. See, this is n factorial. Alright, so that is n factorial. N factorial. Now what is the meaning of this n factorial? It means that it is the product of first n natural numbers. So n factorial is the product of first n natural numbers. Natural numbers are counting numbers starting with 1, 2, 3, 4, so on. Right? There are no negatives, no zero. Alright? So natural numbers. So these are counting numbers. And what is the meaning of n factorial? Product of first n natural numbers. Now, if you have 4 factorial, how do you write it? That will be the product of first 4 natural numbers. 1 into 2 into 3 into 4. So 1 into 2, 2, 2 into 3, 6, 6 into 4, 24 is the answer here. Correct? So 4 factorial is 24, like that. So if you have 1 into 2, okay, you can write into 1 also. Okay, doesn't matter. Even if 1 is not there, still it will be 4 factorial. Okay, it means that you can have anything multiplied by 1, you will get the same thing, correct? Okay, so therefore you don't have to write 1 always. It means that 1 is there, 1 is present. Well, now 2 into 3 into till 43 will be 43 factorial, just like this. Well, so that's the meaning of that factorial notation, and the option C is the answer for that first question. Now let's move on to the second one. Well, the second question has a word AP. Now let me explain that first. What is the meaning of AP? AP stands for arithmetic progression. Alright, so that is arithmetic progression. So if you have arithmetic progression, then what is the condition? I'll explain. See, when do you say A, B and C are in AP? Okay, so arithmetic progression. So in the arithmetic progression, you should have a common difference. Example, let us say I am starting with 2, then I have 5, then I have 8, 11, okay, 14. Now is this arithmetic progression? Yes, because 5 minus 2 is 3. What about 8 minus 5? That is also 3. What about 11 minus 8? That is also 3. 14 minus 11, 3. Correct? So this is common difference. And that is denoted by D. Correct? So D is 3. And this is A. A is the first term. Right? Then you can find the sum of the AP, you can find all those things, you can find the nth term of an AP, all those formulas are there, but we don't need them now. But understand, when do you say 3 numbers are in AP? If there is a common difference. Now, what do you mean by common difference? Second term minus first. So B minus A should be equal to C minus B. Correct? Okay. Now this minus B becomes plus B here. So this minus A becomes plus A. So this is 2B is equal to A plus C. So 2B is equal to A plus C, and that is what you call ABC are in AP. So if ABC are in AP, then 2B is equal to A plus C is the condition. So this is the condition you got to remember. Now they are saying, see, this is like A, this is like B, and this is like C. They are in AP. Then give me the value of X. That's what that question is demanding us. Right? Let us meet that demand. Alright. So let's solve this, and let us understand and find the value of x. Well, now this is the first term, second term and the third term, they are in AP. Then if ABC are in AP implies 2B is equal to A plus C. Well, that's the condition, let us remember. Now we are saying log 2 and then you have got log 2 to the power x minus 5 and 2 to the power x minus 7 by 2 are in AP. So if these three are in AP, then look at this condition 2b. So what is 2b? 2 times the second term. So 2 times log is equal to A plus C. This is A and this is C. Therefore A plus C would be right. Well, now what we do is we use the formulas of log. We need to eliminate this log. Actually we need the value of x, correct? We need to eliminate the log here. So you have log x plus log y. Can we use the formula now? Yes, because the bases are same. You have to note that point, okay? If the bases are same, then only you can use the formula, otherwise you cannot. So we can use the formula log x plus log y. Well, and what about this? What about this? I want to cancel log both sides, but there is this term which is a hurdle for us. Okay, we have to convince him to move somewhere so that I can cancel log. This is not allowing me to cancel. 2 is there in front like a wall. So I have to move him. Okay, so where shall I move him? So you have a formula for that. We can move him to a higher position here. We can make a power of this. Okay, we can make it a whole square here, correct? So we can give him a higher position and then he will be convinced to move. Alright, well, so that's what we will do. So I'll write the formulas here. The formulas are if you have n log m to the base a or whatever, that is equal to log to the base a m. This goes as the power, so we are giving him a higher position. And the next formula is this log x plus log y, and what is it? Log xy. Log xy. Well, so these are the two formulas that we will use and evaluate this. So what happens here is log 2 to the power x minus 5, and this is the base, but this goes as the power here. Okay, so 2 goes as the power, so there is no more hurdle now. And this is log x plus log y, so that is log xy. So this is log, the base will be same 3 and 2 into 2 to the power x minus 7 by 2. Well, now I don't have anything before log. There is no minus, there is no coefficient, so I can get rid of log. Both sides I have log to the base 3. Therefore these two quantities must be equal, correct? So if the log values of them are equal, without log also they must be equal, right? Because log will change its value, this log also will change its value, and both will be equal, correct? Well, so see, this is 2 to the power x minus 5 whole square, and this is, I will multiply 2, okay? So that is 2 to the power 1 into 2 to the power x, and this 2 will be multiplied here, 2 into 7 by 2. Well, now what will happen here is 2 will get cancelled, and that let it be like that. Okay, I'll just write in brackets so that you don't confuse. Well, let us continue. Now what we'll do is a minus b whole square formula can be used here. Therefore, this is 2 to the power x whole square plus b square, that is 5 square, minus 2ab. So 2 into 5 into 2 to the power x. Okay, so 2ba 2ab, same, that is equal to, now this is 2 times 2 to the power x minus, feel free to cancel it, doesn't matter. Okay, so that will be only 7. Now I'll just multiply this. All right, I'll just multiply this, and this, let it be like that. So 2 to the power x whole square minus 10 into 2 to the power x, and that 2 into 2 to the power x, I'll bring it here, that becomes minus 2 into 2 to the power x, and this 25 added, and that minus 7 will be added here. Okay, so now these two things can be simplified and they can also be simplified. So minus 10 minus 2 will be minus 12. So this is minus 12 2 raised to x, correct, plus you have got 25 plus 7, which is 32. Yes, so that is 32. Now what did you get here? Do you see it? It's a quadratic equation, correct? So that's a quadratic equation. So how do you simplify it? How do you simplify it? A quadratic equation, what you can do is you can take 2 to the power x is equal to y. So this will be y square minus 12y plus 32 is equal to 0. Now factorize, you have 32, I need minus 12. So 8 4s are correct. So this is minus 8y minus 4y plus 32 is equal to 0, correct. So this is like y into y minus 8 minus 4 y minus 8. So if you take y minus 8 common, if you take y minus 8 common, you will get two values for y, correct. One value is 8 and the other value is 4. Okay, so you got two values for y, therefore you will get two values for x. So this is 2 raised to x, that is equal to y. Now 2 raised to x is equal to 8 and 2 raised to x is equal to 4. So what should be the value of x here? So that 2 raised to x is 8, 2 cube is 8, therefore x can be 3, correct. So because 2 cube is 8 and here x can be 2, so x is equal to 2. Well, so that is it about second problem. What is the value of x? Yeah, so you have got two values, 4, 3, 2 and 1. Now which value do you select? Do you select 2? Look at this. So if you put 2, this will be 2 square, okay, and that will be 4, and what is 7 by 2? 3.5. So that is fine, you get a positive quantity. But coming to here, if you put x is equal to 2, this will be 4, correct, that will be 4, and 4 minus 5 will be minus 1. Are you understanding? If you take x is equal to 2, if you take x is equal to 2, 2 square 4, 4 minus 5 minus 1. Log does not take a negative number. Log does not take a negative number. Why? Because, understand, see, if you have log x to the base a, now what is the exponential form of this? A to the power y is equal to x. Now imagine you have minus 2 here. Okay, so that means this is minus 2. Now tell me, for what value of y you will get minus 2? Okay, let me take a number here, 10. Okay, now for what value of y you will get minus 2? 10 to the power 0 is 1. What about 10 to the power 1? 10. 10 square, 100. There you will never get negative. Correct? What about negative? You may think for 10 to the power minus 1. What is 10 to the power minus 1? 1 by 10 to the power 1. 1 by 10. 10 to the power minus 2 is 1 by 10 square, 1 by 100. So that will be never negative. Correct? Exponential is never negative. That means log does not take a negative number. Log does not take a negative number. Does it take 0 then? Does it take 0? Tell me, for what value it will be 0? It will never be 0. It will never be 0. Correct? So this value should be always greater than 0. It can be 0.1. Yes, 0.1. It can be 1 by 10. Right? So 0.1 it can be, but it cannot be 0, it cannot be negative. Please remember this. So this quantity should be always greater than 0. So now I am getting negative, therefore this cannot be the answer. Therefore the only answer is x is equal to 3, because when I put 3 here, 2 cube is 8, 8 minus 5 is positive 3. If you take 3 here, 8 minus 3.5, that is also positive, doesn't matter. Okay, it satisfies. Therefore 2 is not the answer. Please remember, only 3 is the answer. That is second question. Moving on to the next question. Moving on to the next question. You have got x is equal to x1, x is equal to x2. Okay, so that does not mean x1 is equal to x2. Okay, it means that you have two roots for this equation. You have got a equation with the condition x is greater than 1. Alright, so x1 and x2 are the two roots of this. Okay, two roots, like quadratic equation, you will have two roots. So these are the two roots, we should add them after getting those roots. So now start with this expression. Question number 3, you have got log x minus 1 to the base 2 plus 6 log 2, that is equal to 5. Okay, now look at this, you have log x minus 1 and 2 base. Here the base and these numbers have shifted their place, so we can have log to the base 2 common. So what I'll do is I will write the reciprocal. See why I am writing reciprocal, because when I write the reciprocal, this will be the base. Correct? So that's why I am writing this, so that I can make things equal here. Now what I'll do? Now I'll take a substitution. So the substitution is y. So this will be y plus 6 into 1 by y, 6 by y you can say, that is equal to 5. Okay. Now take the LCM y. So when you take the LCM, that should be multiplied. So this will be y square plus 6. So that will be y square plus 6 is equal to 5y. Correct? Now next what you can do, y square minus 5y plus 6 is equal to 0. Factorize minus 3 minus 2. So that is like y minus 3 minus 2 can be taken common. Now y minus 3 is taken common. Take y minus 3 common. So what remains is y here and minus 2 here. That means y is equal to 3 or y is equal to 2. Now what is y? Y is this. So log x minus 1 is equal to 3. That's the first value, correct? Next we have to take 2. We'll do that later. Now what is the exponential form of this? 2 cube is equal to x minus 1, correct? See, we need to find this value, so we have to convert it to exponential form. Okay, well, so what is 2 cube? Now what is x? 8 and plus 1, so x is 9. So what did we get? We got the first root. How will you get the second root? Second root you will get by this. So now you take y is equal to 2. So next log x minus 1 is equal to 2. That means 2 square is equal to x minus 1. 2 square is x minus 1. Well, so that is 4 is equal to x minus 1, x is equal to 4 plus 1, 5. So understand, x1 is 9 and x2 is 5. We got two roots. What do you need? The sum of the roots. So add them. x1 plus x2, 9 plus 5, which is 14. Therefore, first option 14 is the answer. Let's move on to the next question. Question number 4. Well, so question number 4, you have log and then log to the base 6. So square root of x minus 3 plus square root of x plus square root of x plus 5, and that is equal to 0, they are saying. Okay, so understand the conversion between log and exponential. So log, if you have this, then a to the power y will be x. So understand that conversion. Well, now what you have is log, and think that this is x and this is y. So I want to write this. I want to write a to the power y is equal to x. Okay, now a. So in place of a, what do you have? 7. Okay, so 7, and what is y? What is y? 0. That is equal to x, correct? So what is x? Log to the base 6 root x minus 3 plus root x plus root x plus 5. Now once again, okay, 7 to the power 0 is 1. Once again, use the same conversion rules. Okay, now in place of a, I have got 6, and in place of y, I have got 1. And what is x? So now for me, x is this. Okay, so x is equal to a to the power y. So a to the power y I have written already, a to the power y. Now this is what I should write here, x. Okay, so that is root x minus 3 plus root x plus root x plus 5. Well, so that is just conversion between log and exponential, and 6 to the power 1 is nothing but 6. Understand now. You have got 4 options given to you. You have got 4 options. Now you have to select one option, correct? And that should satisfy this equation. Now start with the 3. Put 3 here. 3 minus 3 will be 0. Fine. But when you put 3 here, root 3 will not be a whole number. It won't be an integer. Correct? It won't be a whole number. It will be in decimals. it will be in decimals, 1 point something, and that will not add up to give us 6, because when you put 3 here, 3 plus 5 is 8 again, that is also in decimals, so that will not add up to 6. This will be 1 point something, and root 8 is 2 point something. Okay, so that will be 3 point or 4 at the most, it won't be 6. So now put 4 here, put 4, and that will be approximate, will not be perfectly 6. So 3 is not the answer. Put 4 here. If you put 4, that will be 4 minus 3 when x is equal to 4, plus this is 4 and this is 4 plus 9. Okay, so 4 minus 3 is 1, and this is 4 plus 5, I'm sorry, so this is 9. Now this is 1, root 4 is 2, root 9 is 3. What is the answer? 6. 1 plus 2 plus 3 is 6, and that's the answer we were expecting, and we got it. Therefore, which option is correct? Second option. When you put x is equal to 4, it will match. Solving it will be very difficult. You have to square both sides to get rid of the square root, but even then, after squaring, a plus b plus c whole square formula, a square plus b square plus c square plus 2ab plus 2bc plus 2ca. So in 2ab, in 2bc, in 2ca, you will have root and then again root. So root will remain, then again you have to square. So it's a very long process. Therefore, go through the options and check which will fit into the situation. Okay, so now we have got 4 fitting here perfectly and giving us the answer 6. Therefore, 4 is the right choice.
Don't forget to like our video and subscribe our YouTube channel for all the updates.